This video will do some examples using the quotient rule to find derivatives. As a quick reminder before we jump in, the derivative of a function with respect to x that is a quotient, so maybe some u over v, the derivative will be v times u prime minus u times v prime all over v squared. Or you might think of it as v times the derivative of u minus u times the derivative of v all over v squared. Let's do some examples. Let's find the derivative of f of x equals 3x minus 4x cubed all over x squared two different ways. First, we'll simplify it and take the derivative using previous rules like the constant multiple rule and the power rule, and then we will use the quotient rule. So let's simplify first. F of x equals, I can split up my numerator. I'll have 3x over x squared minus 4x cubed over x squared. And this will simplify further to 3 over x minus 4x. And since I'm taking a derivative, I'm going to go one step further with this simplification to make my power rule easier. That is 3x to the negative 1 minus 4x. All right, time for calculus. F prime of x will be negative 3x to the negative 2 using the power rule minus 4. Or if you prefer, you can rewrite it as negative 3 over x squared minus 4. Either of those is okay. Now let's do this same problem, but this time let's use the quotient rule. So f prime of x, it'll be the bottom times the derivative of the top, which is 3 minus 12x squared, minus the top, 3x minus 4x cubed, times the derivative of the bottom, which is 2x, all over the denominator squared. So we're done with the calculus portion. Now it's time to do lots of algebra and cleaning up. So let's see what we get. 3x squared minus 12x to the fourth minus 6x squared plus 8x to the fourth all over x to the fourth. Keep simplifying. It looks like I have negative 4x to the fourths and negative 3x squared all over x to the fourth. And we'll clean this up just a little bit further, just so that we can make sure it does match our original where we simplified it first. So that would be negative 4x to the fourth over x to the fourth minus 3x squared over x to the fourth. And if we simplify, we're getting negative 4 minus 3 over x squared, which we notice is exactly what we got last time. So whichever way we do this problem, we have a choice. Both ways turn out with the same answer, which is good. All of our derivative rules should be consistent. All right, let's do another example. Let's find the derivative of x minus 5 over x. So we can actually do this one both ways as well. We could rewrite this as x over x minus 5 over x, which is 1 minus 5 times x to the negative 1 power. So if we simplify first, like we did last time, then our derivative f prime of x, we just take the derivative using our sum and difference rule. Just go along the line using power, constant multiple, all of those kind of things, and we get 5x to the negative 2, or 5 over x squared, whichever one you prefer. Let's get some practice with the quotient rule though. So if we did use the quotient rule, f prime of x, it would be the denominator times the derivative of the top, which would just be 1, minus the top, x minus 5, times the derivative of the denominator, which is also 1, all over the denominator squared. And we don't need to do a little cleaning up. So this is x minus x plus 5 over x squared. And we see those x's cancel, and we get 5 over x squared, which matches from before. So that's good. We found it 2 different ways and got the same answer. Moving on to our next example. This one looks very familiar to the one we just did, except our numerator and denominator have switched. So we might think we can approach it the same way. However, that would not be okay here. This one does not simplify like our previous one did. We cannot split up a denominator like we can split up a numerator. So we are kind of stuck using the quotient rule here. So f prime of x, so this is our u and this is our v. So it is v, or the bottom, times the derivative of the top, minus the top times the derivative of the bottom, which would be 1, all over the denominator, x minus 5 squared. Now it's time to clean up. So multiply things out. We'd get x minus 5 minus x on the top, x minus 5 quantity squared on the bottom. I see my x's are canceling each other out, and I have negative 5 over x minus 5 squared. There's my derivative. Let's keep going. We have another one here that is not going to simplify. This is not something that we can divide out, if you will. So we can do the quotient rule here. So we have f prime of x equals the bottom times the derivative of the top. And it might help to remember that this is the same as x to the 1/2. Square root of x is x to the 1/2. So the bottom, the derivative of the top would be 1/2 x to the negative half minus the top, x to the half, times the derivative of the bottom, which would be a negative sign, x, all over the denominator squared. Remember that cosine x, if we're squaring that whole thing, the shortcut way to write that is cosine squared x with your square right there. Okay, looks like we should probably do some simplifying here to make this look a little bit better. What can we do? Cosine x, we can do a 2 square root of x in the bottom there. The negative, the minus here and the negative times the sign will cancel. So we'll have square root of x sine x all over cosine squared x. That's not terrible. You could kind of leave it there for kind of what we're doing now. If we did want to clean this up some later, it might help to think of this dividing by the cosine squared x as multiplying times 1 over cosine squared. So cosine x, 2 square root of x plus square root of x sine x times 1 over cosine squared x. So cosine x over 2 square root of x cosine squared x plus square root of x sine x over cosine squared x. And now I'm seeing quite a few things can kind of simplify. So cosine over cosine squared, I can cancel one of those. So let me come back up here. All right. I would have 1 over 2 square root of x cosine x plus square root of x. Now I see I can take the sine x and one of the cosines, and I can change that to a tangent. So tangent x over cosine x. I could keep going. There's no perfect answer here. It's just a lot of different kind of simplifications you could do with your trig. Those cosine x's in the bottom really could be secants in the top. So this could be secant x over 2 square root of x plus square root of x tangent x secant x. That probably looks a little bit better. Definitely looks better than where we started over here. On that note, from the beginning, if we would have wanted to, f of x equals square root of x over cosine x. As it looked, it needed a quotient rule. We could have rewritten this as square root of x. Cosine in the bottom is a secant in the top. And we could have taken the derivative that way. However, we still need a little bit of help before we can take the derivative of secant x. And we're going to get to that in just a few minutes, and we'll talk about it. So then use product rule. We turned the quotient rule into a product rule. But again, this secant x, we're going to get to it in just a little bit, what its derivative is. All right. Let's find the derivative of -7 over x to the 5th. So if we jump in and we know, okay, we're in the quotient rule section, we might think, okay, that's u and that's v, and start going with the quotient rule. However, I'm going to simplify first. This is a great case of where doing a little extra work at the beginning makes the derivative much easier. So this is -7x to the -5. This is just a power rule situation. F prime, using the power rule and the constant multiple rule, is just 35x to the -6, or 35 over x to the 6, whichever one you prefer. So just because you see a fraction, don't always assume you have to use the quotient rule. Because that numerator was just a constant, I could just rewrite this using the power rule property, or the exponent property, so that it was in a power rule form. Makes it a lot easier. All right, let's look at another one. Let's find the derivative of tangent x. And so you may be asking yourself, why is this in this section? Why are we finding the derivative of tangent in the quotient rule section? And the answer is, we are going to find its derivative by thinking of tangent x instead as sine x over cosine x. Now it's set up as a quotient where we know the derivative of both sine x and cosine x. So we can use the quotient rule to come up with a formula for the derivative, or the answer to the derivative of just plain old tangent x. So f prime of x will be the bottom times the derivative of the top, so sine x. Oop, what am I doing? The derivative of the top, cosine x, minus the top times the derivative of the bottom. Derivative of cosine x is negative sine x, all over the denominator squared. So let's do some cleaning up. I'll get cosine x times cosine x would be cosine squared x, and negative sine x times negative sine x will be a positive sine squared x. This is all over cosine squared x. And now I look at the numerator. I have cosine squared x plus sine squared x, and you should remember from trig that sine squared theta plus cosine squared theta is 1. So I can trade out that numerator for a 1. This is over cosine squared x. But a cosine in the denominator is a secant in the top, so this is a secant squared x. So we've gone through the quotient rule to show that the derivative of tangent x, so the derivative of the tangent function, is always secant squared x. Okay, so this is when you should learn. This is, tangent's one of our basic 6 trig functions. You should know its derivative, just like we learned sine's derivative and cosine's derivative. Now tangent is one you should know. However, should you ever forget what tangent's derivative is, you can always fall back on doing the quotient rule, rewriting tangent as sine x over cosine x. All right, let's do another one. Let's find the derivative of secant x. So again, this is another one of our basic trig functions. This is one that we should just know its derivative eventually. But to get its derivative, we're going to use the quotient rule and the fact that the secant function would be 1 over the cosine function. Okay, so let's use the quotient rule here. So f prime of x will be the denominator, so cosine x, times the derivative of the top. And what's the derivative of 1? Well, its derivative will be 0, minus the numerator, the top function, 1, times the derivative of the denominator, and derivative of cosine is negative sine x, all over the denominator squared. So let's do a little bit of cleaning up. That 0 is just going to multiply and cancel those out. So I'm left with a positive sine x over a cosine squared x. And I can keep going a little bit further here because I'm going to think of this. I'm going to sort of pull it apart. This is a sine x over a cosine x times a 1 over a cosine x. Sine over cosine is tangent x, and 1 over cosine is the secant function. So the derivative of the secant function is tangent x times secant x, although normally we see it written as in textbooks as secant x tangent x. That's the same. We can multiply in any order, but that's just normally what we see. So the new rule we've learned, the derivative of the secant function is secant x tangent x. And that's another rule that you need to know. Add that to your list of derivatives that you can just kind of answer. And then if you ever forget it, you can fall back on doing the quotient rule. Okay, so let's kind of make a little summary real quick, make sure we know all these. The derivative of the sine function is the cosine function. The derivative of cosine is negative sine. The derivative of tangent is secant squared x. The derivative of the secant function is secant x tangent x. And then these last two, the derivative of the cotangent function and the derivative of the cosecant function, what you're going to find is you can do a very similar method as we did with the tangent function and the secant function. You can remember that the cotangent of x function is the cosine of x over the sine of x, and the cosecant function is 1 over the sine of x. Notice we can write both of those as fractions, and then we can go through the quotient rule and figure out their derivatives as well. So that's an exercise that you should do on your own, is to go through and figure out what should go here and here. What are those two derivatives? Okay, so go through, do the quotient rule using cosine x over sine x and using 1 over sine x. And then once you're done, check real quick in your book or on the internet and see what the answer should have been and make sure you get there. Here's a hint. You should sort of notice a pattern happening in this box. And that should help you remember these derivatives.